Now, number 2, in the figure below, number 2, and this is the figure. In the figure below, AB is the diameter of semicircle ABCD. If angle ABD is equal to 16 degrees, calculate angle BCD. Int, join C to A. We want to find this angle BCD. This angle. Now, they said we should join C to A. Let's say that. Join C to A. If we join C to A, what do we have? How does that help us find angle BCD? Now, if we join C to A, that means this angle is a right angle, angle in a semicircle. Angle BCA is equal to 90 degrees, and the reason for that is angle in a semicircle. Now, we'll see that this angle and this angle are equal, angles in the same segment. Angle ABD, angle ABD is equal to angle ACD. And the reason for that is angles in the same segment. Angles in the same segment. And that simply means angle ACD is also equal to 16 degrees. So this small angle is also equal to 16 degrees. And that therefore means, angle BCD, which is the angle we want to find, is equal to 90 plus 16 degrees. 90 plus 16 degrees. That's BCA, angle BCA plus angle ACD, which is equal to 90 plus 16 degrees. Angle BCA plus angle ACD, which is equal to 90 plus 16 degrees, and that's 106 degrees. So angle BCD is equal to 106 degrees. And that's it, very, very simply. Let's now go to number 4. Number 4, let's have a diagram first of all. Number 4. Let's have a diagram. Let's say diagram. This is a piece of cake. It's very, very simple. The question is very, very simple. If you remember all of the rules, it will be very easy. And there's a straight line here. Let me draw that well. Now this is, okay, there's a line here that joins these 2 points. Now this is A, that's B, C, D, and this is E. Now this angle, we want to find this angle. This angle is 47 degrees, while this angle is 102 degrees. Now the question says, in the figure below, ABCD are points on a circle such that angle ABC is equal to 102 degrees. This is angle ABC. CD is produced to E, the length CD is produced to E, so that CD is produced to E so that angle AED is equal to 47 degrees. Angle AED is 47 degrees. Calculate angle EAD. We want to find this angle EAD. What's the first thing to do here? Find angle EAD. First of all, we can see that this angle is an exterior angle to the cyclic quadrilateral ABCD. And we know that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. If you complete this part, the angle here is going to be 180 degrees, and the side facing what you need to make this 180 is the angle facing, if you complete this angle, This is the part that makes the whole of this 180. This is the part that you need to add to this to make it 180. So the angle facing this one is the interior opposite angle. That's a trick to always get the interior opposite angle. Just think of the part you need to add to the exterior angle to make it 180 degrees, and it is this. It is this angle. So the angle facing that angle is the interior opposite angle. So that means angle, that simply means angle angle ADE, angle ADE is equal to angle ABC. And the reason for that is exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. And that therefore means angle ADE is also equal to 102 degrees. Now that we know angle ADE, we can easily find angle EAD. So angle EAD plus 47 plus 102 degrees equals 180 degrees, angles in a triangle. So that means angle EAD will be equal to 180 minus 102 plus 47. Since we already know that 102 plus 47 plus angle EAD is equal to 180 degrees. That means angle EAD will be equal to 180 minus the sum of 102 and 47. And that means angle EAD is equal to 180 minus 149. And therefore angle EAD is equal to 31 degrees. And that's it, very, very simply. This is 180. That means angle EAD equals 31 degrees. And that's it, very, very simply. Number 6, we have a diagram. It's good to make the diagram bold. It makes it work easier and neater. Now, QP, this is QP. This is QP. There's a line here. There's a line here. Let's have it this way. This goes this way. And this way. Well, there's a line here. Now, this is TSR, and this is X. Now, we want to find this angle PXR. This angle is 20 degrees, and this angle is 80 degrees. This angle is 80 degrees. This angle is 80 degrees. Now, what size is angle PXR? In the diagram, angle PQR is equal to 80 degrees, and angle SRT is equal to 20 degrees. What size is angle PXR? How do we find angle PXR? What do we do here? Let's see that angle PXR. Find angle PXR. Okay, oh, that's simple. That's a piece of cake. Angle PQR plus angle PSR is equal to 180 degrees. And the reason for that is opposite angles of a cyclic quadrilateral are supplementary. I can see that PQRS is a cyclic quadrilateral. So that means angle Q in that cyclic quadrilateral plus angle S is 180 degrees. So I'm going to say angle S is equal to 180 minus 80. 180 minus 80. And the reason for that is opposite angles of a cyclic quadrilateral are supplementary. Angle Q plus angle S is equal to 180 degrees. Angle P plus angle R is equal to 180 degrees because they are opposite angles of a cyclic quadrilateral. Or if you like, you can label this angle S, PSR. It's the same thing. Now, angle S equals 180 minus 80, which is equal to 100 degrees. Now, if this angle is 100 degrees, then I can find this small angle. I can now say RXS, this angle plus this angle plus this angle is 180 degrees. RSX, angle RSX Angle RX, this one, S, RXS, angle RXS is equal to 180 minus this angle plus this angle plus this angle. So 180 minus 80 plus 20. And the reason for that is sum of angles in a triangle. Let me write that 80 properly. We know that 20 plus angle S, which is 100, plus angle RXS, which is this one, is equal to 180 degrees. That means angle RXS will be 180 minus the sum of 20 and 100. 20 degrees and 100 degrees, and that simply means 180 minus 100, and that means angle RXS is 80 degrees. Now that we know angle RXS, if this one is 80 degrees, then we know that, in fact, why was I even finding angle RXS? That was very, very unnecessary. Let's go back. Let's go back. We can find, we didn't need to find angle RXS. We can see that, let's take that out. If this is 100 degrees, if this angle is 100 degrees, then angle PXR, which is this angle, is going to be 100 plus 20. And the reason for that is exterior angle of a triangle is equal to the sum of opposite interior angle. Let me bring out that triangle. This is a triangle. This is a triangle. Triangle. Let's bring out that triangle. I want to bring out triangle. This triangle. Triangle XSR. I'm bringing out triangle SXR. Bring out triangle XSR. And this is what it looks like. Triangle SXR looks like this. Triangle XSR. And this side XS is produced. That side XS is produced to P. This side SX is produced to P. That means this is an exterior angle, and it's going to be equal to the sum of opposite interior angles, which will be this angle plus this angle. And I know that this angle is 20 degrees and this angle is 100 degrees. So that therefore means angle PXR, let me place the X properly. That simply means angle PXR equals 100 plus 20, which is equal to 120 degrees. And the reason for that is exterior angle of a triangle is equal to the sum of opposite interior angles. And that answers the question very, very simply. So we go to the next one, which is number 8. Number 8. In the diagram below, PQRS is a cyclic quadrilateral such that angle QPR is equal to 18 degrees and angle RQS is equal to 42 degrees. If angle PSR is equal to 78 degrees, calculate the angles of triangle PQS. What kind of triangle is triangle PQS? Okay, PQRS is a cyclic quadrilateral. Let's have a shape. Now let's put the quadrilateral inside it. PQRS is a cyclic quadrilateral. PQRS is a cyclic quadrilateral. Let's say diagram. Let's say diagram. Join this to this. Now this is PQRS. That's it. Cyclic quadrilateral PQRS. PQRS. Now this angle is 42 degrees and the whole of this angle is 78 degrees. 78 degrees, while this is 18 degrees. Now the question says calculate the angles of triangle PQS. We want to find the angles of triangle PQS. That means we want to find this angle, and this angle inside triangle PQS. So let's go. How do we do that? Now, first of all, we can see that if this is 18 degrees, then this will also be 18 degrees. And the reason for that is angles in the same segment. So angle QSR is equal to 18 degrees. Angle QSR is equal to angle QPR is equal to angle, or let's see, angle QPR. Angle QSR is equal to angle QPR. And the reason for that is angles in the same segment. So that therefore means angle QSR is also equal to 18 degrees. Now, if we know that this is 18, then we can find this angle in triangle PQS. We can find angle PSQ. So that therefore means angle PSQ in triangle PQS is equal to 78 minus 18. 78 minus 18, which is equal to 60 degrees. Now we have found one of the angles of triangle PQS. Now, which other one can we find? Let's see that. What else can we find? Okay, if this is 42 degrees, if this angle is 42 degrees, then this angle will also be 42 degrees. And the reason for that is angles in the same segment. Angles in the same segment. You can see that this chord, here there's a chord here which divides the circle into two segments. This minor segment and this major segment. So you'll see that these two lines, this line and this line, form an angle at the circumference of the circle by touching the extreme ends of the chord. And this line and this line also meet at the circumference to form an angle. And they also touch the extreme ends of the chord that divides the circle into two segments. So those two angles formed are going to be equal. This one and this one, they're going to be equal. That's just a trick for identifying the same segment angles so that you don't get confused. So that simply means angle RQS is equal to angle RPS. Angle RQS is equal to angle RPS. Angle RQS is equal to angle RPS. And the reason for that is angles in the same segment. So that therefore means angle RPS is also equal to 42 degrees. This is 42 and this is also 42 degrees. Now, if we know angle RPS, then it means we already know angle QPS in triangle PQS. This is also 42 degrees. So we can now say, therefore, angle QPS will be equal to angle QPS in triangle PQS will be equal to 18 plus 42 degrees. That's the whole of this. 18 plus 42 degrees, and that is 60 degrees. That's 60 degrees. Now we're left with just one more angle. Now that we already know two of the angles of a triangle, we can find the last one. We know this one, this is 60, and this is also 60 degrees. That means this will be 180 minus 60 plus 60 is 120, and this one will be 180 minus 120. So angle PQS is equal to 180 minus angle QPS plus angle PSQ. 180 minus QPS plus PSQ. Let me find a way to make sure that I can write that on a single line. Angle PQS, which is this angle PQS PQS is equal to 180 minus angle PSQ, which is this, my plus angle QPS, which is this, PSQ plus QPS plus QPS, and that's equal to 180 minus 60 plus 60, which simply means 180 minus 120, and that is 60 degrees. So that therefore means angle PQS is also equal to 60 degrees. So we have found all of the angles of triangle PQS, and now the next question says, what kind of triangle is triangle PQS? Triangle PQS is therefore an equilateral triangle because each of its angles is 60 degrees. That means all of its sides are also equal. Side length PQ will be equal to length PS, which will also be equal to length QS. Triangle PQS, therefore, triangle PQS is an equilateral triangle. It's an equilateral triangle. Triangle PQS is an equilateral triangle. Now let's go to number 10. Number 10A, in the figure below, O is the center of the circle, and A, B, and P are points on the circumference. And A, B, and P are points on the circumference. Prove that angle AOB is equal to 2 times angle APB. Oh, this is just the proof that angle at center is twice angle at circumference. We've done that already. We don't need to repeat that. Now, let's see question B. What does that say? Question B says, in the figure below, PQRS are points on a circle such that angle PQS is equal to angle PRQ. Angle PQS, which is this angle, PQS is equal to angle PRQ, which is this angle. Now, the question says, Roman figure 1, prove that PS, the length PS is equal to the length PQ. Okay, let's see that. PS is equal to length PQ. Let's go to Roman figure 1. First of all, I can see that angle PSQ is equal to angle PRQ. And the reason for that is angles in the same segment. Angle PRQ equals angle PSQ. And the reason for that is angles in the same segment. Yes. Angle PRQ equals angle PSQ. So that means this angle is also equal to this angle. And what that also means is this angle will also be equal to this angle because this angle and this angle are equal. So now, so that's it. I can now see that angle PSQ is equal to angle PQS. And if a triangle has two equal angles, it means it's an isosceles triangle. And that means it has two equal sides. And in this case, the equal sides will be PS and PQ. So what this therefore means is that angle PSQ is also equal to angle PQ. Let me write it this way. I think it will be clearer this way. We know that PQS, PRQ is equal to PQS. This angle is equal to this angle. So what that therefore means is that PQS, which is this angle, will also be equal to PQS. Therefore, PSQ will also be equal to PQS, will also be equal to angle PQS. And that therefore means triangle PSQ or triangle PQS is an isosceles triangle. If these base angles are equal, that means PS is equal to PQ. Therefore, PS equals PS equals PQ. PS equals PQ. And the reason for that is because it has two equal base angles. So that's a proof. Now let's go to Roman figure 2. Roman figure 2, what does that say? Roman figure 2. If SQ is a diameter of the circle, if SQ is a diameter of a circle, SQ, if it's a diameter, if SQ is a diameter of a circle, if SQ is a diameter of a circle, before we go to that, I can add here that the reason here is that triangle PQS is isosceles. Triangle PQS is an isosceles triangle. It's isosceles. Now let's go to Roman figure 2. If SQ is a diameter of the circle and QR is produced to Z, QR is produced to D. If we produce QR to Z, QR is produced to Z. Let's do that. That means make QR longer and stretch it to a point Z. QR is produced to Z. QR is produced to Z. This is point Z. That's point Z. Determine angle SQP and angle SRZ. Now SQ is a diameter and QR is produced to Z. I now want to find angle SQP and angle SRZ. I want to find angle SQP, this angle SQP, and angle SRZ, and this angle SRZ. Angle SRZ. Okay, to find angle SRZ, I have to join S to R then. SRZ. I want to find this angle to SRZ. So how do we do that? Now let's see, what do we do here? Angle SRZ. Okay, if SQ is a diameter, if SQ is a diameter of the circle, that simply means angle SRQ is a right angle. And the reason for that is angle in a semicircle. Angle SRZ is, angle SRQ is 90 degrees. Angle SRQ is 90 degrees. And the reason for that is angle in a semicircle. Angle SRQ, let's go that way. SRQ equals 90 degrees. And the reason for that is angle in a semicircle. Angle SRQ equals 90 degrees. Angle in a semicircle. Now that we know that, we can find SRZ immediately. That means SRZ is also 90 degrees. SRZ plus SRQ equals 180 degrees. Angles on a straight line. So I can say, therefore, SRZ is equal to 180 minus 90. And the reason for that is angles on a straight line. And that therefore means angle SRZ is 90 degrees. Now we want to find angle SQP. How do we find SQP? SQP. That's simple. We know that SRZ, okay, maybe we are not there yet. We know that, okay, maybe we are not there yet. Let's say that. Oh, that's also very, very simple. I can see that quadrilateral PQRS is a cyclic quadrilateral. Quadrilateral PQRS is a cyclic quadrilateral. So that means, and one of the sides of that quadrilateral, which is QR, has been produced to Z. So that means this angle is an exterior angle. And the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. And this is going to be the opposite interior angle. So that means angle SPQ is also equal to 90 degrees. angle SPQ equals angle SRZ. Exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. This is how you know the opposite interior. This is what you need to make it 180. So the angle facing this angle is the interior opposite angle. So what do I say? I'm going to say angle SRZ, angle SRZ is equal to angle SPQ is equal to angle SPQ equal to angle SPQ. And the reason for that is exterior angle of a cyclic quadrilateral is equal to the interior opposite, is equal to the opposite interior angle. That therefore means angle SPQ is also equal to 90 degrees. Angle SPQ is also equal to 90 degrees. Now, I know that angle PSQ and angle PQS are equal. So, I can easily find angle SQP. So, let me do this. Let angle PSQ, first of all, PSQ, let me do this. Let angle PSQ, which is equal to angle Q, which is equal to angle SQP, which is equal to angle SQP, be equal to W. Let each of those angles be W, be equal to W. So that means this is W and this is also W. So I can now say, therefore, 90 plus W plus W equals 180 degrees. This is 90, this is W, and this is W. 90 plus W equals 180 degrees. And the reason for that is angles in a triangle, or if you like, sum of angles in a triangle. And that simply means 2W, W plus W is 2W, will be equal to 180 minus 90, which means 2W equals 90. Now we can divide through by 2 to get W. That means W equals 45 degrees, which therefore means angle SQP is equal to 45 degrees. Angle SQP is equal to 45 degrees. And that's it, very, very simply. You can't miss it if you know the rules and you apply them correctly. And that's it, very, very simply.